Okay, there's a question. Which one? Which is a section B question. Cara Kamban. No, wakamboita aku. Because haungaendi muexam usinomboita Cara hazvitenderi. It's an offense. And this one is limiting factor analysis, but where we have all right, so it's fine. It's okay. It's a limiting factor analysis question. But in this case, we will be having more than one limiting factor. And when we have got more than one limiting factor, it means that we are going to use linear programming. Okay? Linear programming. Atigone kupinda exam ye ACCA performance management. Tisina kuita linear programming. Tinocha. We are going to pin an exam, tisina kuita tese. The chico learning curve, the learning curve. And the learning
curve and learning rates.
And
but you can bring on that one, and you can bring a question and then you try and jog my memory. I think ndakaita
tichaita one ipapa apa tisataenda kumba toziva kuti tapedza ipapa takavha tinenge tambozama kufamba saka tifambe this question tongoipa 10 minutes chete. All right.
10 minutes.
This okay, one. Sir. The 5 questions, all the 5 questions, we're going to do them in the next 10 to 15 minutes. Kana zvazonetsesesa tozosvikawo edu pa 20 minutes. Okay. Cara company makes 2 products. So this company is making 2 products, the seabirch and the head of. To make a unit of each product, the following resources are required. So these are the resources which are required. Okay, materials, $100 per kg. Remember, we are making 2 products, the seabirch and the head of. The seabirch requires material 5 kgs per unit. Remember, we are told that to make a unit of each product. So per unit, we need 5 kg of seabirch and 7 kgs of materials for head off. Then labor, we are charged $45 per hour, and we need 2 hours to make a seabirch. We need 3 hours to make a head off. Machine hours, $60 per hour. We need 3 hours to make a seabirch and 2 hours of 2 machine hours to make a head off. Fixed overheads are $300,000 each month. Remember, fixed overheads would require us to meet them, regardless of the fact that we did not produce anything. You see, that's the danger and cruelty of fixed overheads. You meet them even if you do not do any production. Now, the contribution per unit made on each product is as follows. So the seabirch gives us a contribution of $250 per unit and the head of $315. The maximum demand each month is 4,000 units of seabirch and 3,000 units of head of. The products and materials are perishable, and inventories of raw materials or finished goods cannot be stored. So you just have to produce them and deliver, produce to sell.
Mm-hmm.
So those are the, some of the details which you will use when you do some discursive parts, especially if it was a section C question. Those are the things you need to consider. Cara company has a legally binding obligation to produce a minimum of 2,000 units of head of in each month. So there is a legally binding obligation. When there is a legally binding obligation, no matter we have done a production plan, an optimal production plan where we do the rankings, you would have to realize that even if this particular product, maybe the head of, is the last one to be produced. But because there is a legally binding contract, we need to produce it, whether it has got the contribution per limiting factor, which is lower than the rest. It has to be given prominence. Are we together?
Yes,
So, Cara has a legally binding obligation to produce a minimum of 2,000 units of head-off in each of months 1 and 2. There is no minimum production required in month 3. The manufacturing manager is planning production volumes and the maximum availability of resources for month 1, 2, and 3 are as follows. So these are the production volumes and maximum availability of resources for the month. So materials in kgs, in month 1, we are going to have 34,000, month 2, 42, month 3, 35. Labor hours, 18,000 in month 1, 12,000 in month 2, 24,000 in month 3. Machine hours, 18,000 in month 1, 19,000 in month 2, 12,000 in month 3. For month 3, the following linear programming graph has been produced. So for month 3, we are having this graph. Okay?
Yeah.
This is the graph where we are given the information for month 3. So what our examiner usually does, so this is the axis that shows figures for the head-off, and this one is the axis that shows production for the C batch. Now, what the examiner does in these papers is that he is always organized. So the questions are usually going to be arranged in the manner in which the information is presented in the scenario. All right. So they first start to talk about month 1 and month 2, then lastly month 3. That's when you see that graph is for month 3. So zvinhu zvacho zvakangorongeka kuitira kuti usarasika muzama. Ukazoti ndakarasika ndakashaiwa, unofanira kungoziva kuti ndainga ndingoriwo zvangu ndingoriwo nepressure dzangu, but zvinhu zvaita sei zvaipasika. So the first question, what is or are the limiting factors in month 1? So we come back here. The information has been presented to us. We are told of, since we are planning volumes, we are planning production volumes and the maximum availability of resources for month 1 are as follows. So maximum availability of resources will tell us if we have got certain things which are in adequate supply. So we then have to ask ourselves, do we meet the production demand? Because maximum demand information is here. In month 1, for us to meet the production demand, remember we need to produce 4,000 units of C batch and 3,000 units of head-off. Do we have the necessary resources? Do we have enough materials? Do we have enough labor? Do we have enough machine hours? That's the question we need to ask ourselves, isn't it? Good. So let's start to ask or to confirm if materials are in adequate supply. So how do we do that? Okay, we can do it in Excel so that we just seal it once and for all. What's going on here? I wanted to share my screen so that this thing can't move. What is it? Yeah, just to move. Are you seeing double screen right now?
Yeah, now you're sharing both. You stop playing with both.
All right, that's great. So for month 1, okay, let me just say for question, what question number is this one? It's question 16, right? Okay, question 21. For question 21. Okay, so we're going to say let us say C batch head of units produced, units demanded. We can just say here demand. For C batch, we are told in the question that the demand is how much? Because we are told, remember, we were told by the examiner that you can't store these things, right? They are perishable. So you need to, whatever you produce, you sell. That's the assumption, isn't it? You produce what you can sell. So the demand is informing us that those are the quantities that have to be produced. So for C batch, that's 4,000 units. For head of, 3,000. Now, materials. C batch requires how many units? How many kgs per unit? 5, right? 5 so equal to 5 multiplied by how many units? 4,000. So we need 20,000 kgs. Now for head of, it's 7 kgs per unit multiplied by 3,000 units. So the total is equals that plus that one, 41,000 available. How many units are available? We have got 34,000 from the question.
4,000.
We've got 34,000, right? Hello? Did you see that?
Yes. Under month 1.
Yeah. And the question is asking us for month 1, isn't it? So, do we have a limiting factor here?
Available is 34. And then available is 34 years.
And then the total
the one that
required.
We want.
This is total
is 41.
required.
All right, Saka, we do have a limiting factor there.
Yeah, yes.
Because here they are demanding more than what we can provide.
You understand, right? Good. For materials, it's a limiting factor. What about labor?
Mira it honestly, ndaona Excel isingabudi ndauda kunyora zvinhu muExcel manje. I like the way you presented it there.
Okay.
Then total required. Then available.
So are we together?
Yes.
Now let's move on to the labor part. Okay, labor. We are told that C batch requires 2 hours. Okay, a C batch requires 2 hours. So equals 2 multiplied by how many C batch? 4,000. Just do the same. All right, and we come to the head of requires 3 hours per unit multiplied by 3,000, and we just drag our formula. And how many hours are available? The hours available is, according to the question, we have got 18,000 hours. So is there a limiting factor? Is this a limiting factor? We require 70,000, but we have got 18,000. So this one is not a limiting factor. We come to machine hours. Machine hours. How many machine hours are required for a C batch? 3 hours, equal sign 3 hours multiplied by total number demanded 4,000. That's 12,000. Then in terms of the head off, they require 2 machine hours multiplied by the total number demanded 3,000. And we drag our formula again. 18,000. And how many hours are available? We have got 18,000. So is this a limiting factor? Obviously not.
Almost there with you, sir.
So what is our answer? What is our answer?
Becomes materials.
So what is the answer?
The question? Limiting factor.
What is
material only?
So the answer is C, right? So you can see that limiting factor analysis is just as simple as like eating a cake, isn't it? Okay, let's move on to number 22. Question 22. The production manager has identified that the only limiting factor in month 2 is labor hours. What is the production volume for head off for month 2? So the limiting factor in month 2 is labor hours.
That's what they say too.
I mean, the question is saying the production manager has identified that the only limiting factor in month 2 is labor hours. So what is the production volume for head off for month 2, given that the only limiting factor is labor hours? So on my scratch pad, I simply say if labor hours are the only limiting factor, here is the production plan. Here is the production plan. Okay. Let me get back to the question to come up with the production plan. We have got C batch. We have got head off. Don't mind my spelling there for the head off.
Wrote S and H. I don't know why people will write it in full. Huh?
Okay, all right, that's fine. That's fine. All right, so let's start with the contribution, right? The contribution per unit for this. For the head off, for the C batch is 250, and for head off 315, right? So 250, 315. And the limiting factor is what? Is labor. Since it has already been identified by the examiner, isn't it? So we require 2 hours of labor per unit and 3 hours for the head off. All right. So what is the contribution per limiting factor?
We divide.
Per limiting factor, right? So that's equal sign 250 divided by 2. 125. We drag the formula. 125, 105. So ranking, our ranking, which one should be produced first?
125.
And this one second. That's the ideal plan, isn't it? But because there is a contract, because of the binding contract, the binding obligation, we start with 2,000 head off. Are we together? We start with what?
Yes,
2,000 head off. So let's start with the 2,000 head off to see if we are going to get other additional head offs. Because the question is actually saying, how many quantities of head offs are we going to produce in month 2?
It's 2,000.
So if we are saying, if we are producing 2,000 head of, okay, let me just say H here, 2,000 units, all right, and how many hours are we going to use? How many labor hours are we going to use?
3.
And total, let me just say hours used. Equal sign, we are saying we are producing 2,000 units multiplied by how many hours? A head of takes how many hours? Here, 2. Takes how many hours? Takes 3 hours, right?
Takes 3.
3 hours, right? 3. So we have used 6,000. And how many are available in month 2? How many hours are available in month 2? We come back to the question here. In month 2, there were 12,000 hours. Isn't it? Labor hours. Are we together?
Yes.
Remaining hours, that's equal sign 12,000 minus the hours used. We are left with 6,000 hours. These are remaining hours. Now, we then have to go for the first, for the C batch. Why? Because after we finish the contract, we just have to run to that product that gives us the highest contribution possible. That's the C batch, isn't it? We have satisfied our obligation, but we need to make profit. We need to make the highest contribution possible. So we run to that first product in our ranking order. So we come here to say C batch. Okay, C batch. The C batch. Now we are left with 6,000 units with 6,000 hours. Remember, we need to see if we still have got something. Sometimes if we simply say, let us pick the full 4,000, the 4,000 units of C batch, let us try. If we say 4,000 units of C batch, right? But each, if we say 4,000 multiplied by how much, how many hours per unit? That's 2 hours per.
That's 2.
2, right? So you see that we would use 8,000, but we are left with only 6,000. So it's impossible, right?
Pretty much so.
Yeah. So sometimes it's better to do reverse engineering, right? So if we start with the, okay, so we know that we have got 6,000. So if we come here and say 6,000, is that going to work? Let me see. Okay. Obviously, the hours which we are going to use are 6,000, right? So which means if we are using 6,000, here should actually be 0, right? Because we are going to be left with nothing if we use 6,000 here. All right. And then the quantities which we are going to make should be equal sign 6,000 divided by the hours per unit. That's how much? For the C batch, we need 2 hours, right?
We need 2 hours, but then wait, muri kumhanya. Tati, ndasarira pakuti tiri kuita reverse engineering. Tatora remaining hours 6,000 ayai. Taakudzokera kumasure takuenda hours used. Ndopataita 6,000 here. Kana kuti hours used. Hapasi panosara 8,000. Chii chinoitika basa?
Kuti isusu anti. Ita reverse engineering and it first of all, we tried to just do it the normal way, but it showed us that we are only, because the normal way actually the best okay, the normal way gives us the self-checking mechanism, where we are saying the normal way was saying the C batch demand was the 4,000 here. This was the demand. So if we put 4,000 here, that was the demand, right? But the hours required, or the hours which we are going to use if we say we want to produce 4,000, we are going to use each C batch takes 2 hours to produce, right? 2 multiplied by the 4,000, this 4,000. We can see that we require 8,000 units, 8,000 hours. But what we have in inventory is 6,000. Do you get it? So we are forced to then start from the hours remaining, going backwards. Why? Because we have seen that all the C batches to be produced are going to exhaust all the hours remaining. So automatically, we are going to say hours used are 6,000. Okay? The hours used are 6,000, but 6,000 should then give us how many quantities? That's equal sign 6,000 divided by the hours taken to produce 1 unit. That is 2 hours of C batch here. Right?
All right.
So this is going to give us 3,000 units of. But now that stage, was it necessary? Yes, it was necessary for us to see if there are any remainders. Okay, the moment you see, for the purpose of this multiple choice question, the moment you see that the C batch, the 4,000 here, the demand, according to the demand, was going to exhaust all the remaining hours and leave out some extra hours missing, then you would only be able to detect that for the head off alone, we're only going to produce 2,000 and not anything more in terms of the head offs. Head offs are only going to be produced 2,000 in terms of quantity. These are the quantities, quantity produced.
Yes. Yes, sir.
Do you get it? Or maybe you're lost.
No, I'm almost there, but I'm not lost.
You replay the video anyway. So that's the idea, right? But let me just put the full name here because I know you. Head of. So what is our answer? If we come back to our question, the question was saying, what is the production volume for head of for March 2 to the nearest war unit? So you can see that the answer, the head offs that we are going to produce are only 2,000 units. So this was the answer, 2,000.
But did we have to work it out since we were told already that it was a contract?
What are you saying?
No, I didn't say anything, sir.
Okay, yeah.
Hello?
Yes, some workings are necessary, and those are the workings which we have shown you. Those are actually necessary workings. Otherwise, if you don't do those, you are not going to excel. You end up guessing. Anyway, let us now move on to a little bit mature stuff. 23.
There I was just saying, putting production volume a month to say, because of that statement here, contractual obligation, wasn't it definite that 2,000 units were going to be taken besides the workings?
Okay, it wasn't going, if there was no contract, remember, we were going to first exhaust the 4,000 C
Exactly
batch.
like we did.
Yeah, because the C batch, remember, the C batch are the ones giving us more contribution per limiting factor. You understand?
Mm.
They're giving us 125 per labor hour, $125 per labor hour. So we were supposed to have produced all the 4,000 C batch if there was no contract there. Do you get it? And maybe in terms of the head offs, maybe we're producing something like 1,000 or so, the remainder. Do you get it? If there was
Yes,
no
sir.
contract.
Oh, yeah.
Do you get it?
Yes, sir.
Great. Let's move on to 23. Any, we don't have time, right?
I'm here, sir.
Number 23. If the shadow price for March 2 is $125 per labor hour, which of the following statements is or are correct? Number one, okay, what is the shadow price?
Shadow price, is it? I know, is it shadow price? Is this the price that we charge for an extra unit that gives us
Yes.
profited?
Yes, it's the extra
Is it?
contribution which we get after we add a unit of a scarce resource.
That's the result.
Scarce
So an
resource,
extra
yes.
contribution
We get
we
after
get from
adding a
AD.
unit of the scarce resource or of a scarce resource. So that's the definition of a shadow price. The contribution earned from having one extra unit of limited resource available and is also the extra on top of the existing cost for that limited resource, which a company would be willing to pay to continue that extra resource. Sometimes is the extra unit we are likely to pay, or which we are comfortable to pay to enjoy the scarce resource, or the extra contribution we earn after adding the scarce resource. All right. So if the shadow price is $125, as in this question, it would mean that Cara, remember, it's $125 per labor hour. So if the shadow price for month 2 is $125 per labor hour, it would mean that Cara company would be willing to pay $125 of overtime premium per hour for the next $2,000. Remember, from our definition, it is that extra cost we are going to be comfortable paying if we add a unit of labor, or if we add an extra labor hour. All right. So don't mind these 2,000 hours. All right. It's not really important whether they say 5,000 hours for the next 5,000 hours or for the next 10 hours, but you just have to understand the theory. So the shadow price is that extra contribution we are going to earn, or that extra cost we are going to incur if we add an extra unit of the scarce resource. So here is the production manager will be willing to pay existing staff a maximum overtime premium of $125 per hour for the next 2,000 hours. All right. So if it is actually, if 125 is a shadow price for labor, then it simply means that the manager would be willing to pay existing staff a maximum overtime premium. Remember, overtime is an extra resource after the normal production time. So that extra overtime attracts an extra cost, which is called an overtime premium. So the production manager will be willing to pay that maximum overtime premium of $125 and nothing more, but up to $125. Why? Because $125 is the shadow price of labor. Any additional labor is going to attract $125. Now, so number 1 is correct. Number 2, the production manager would be willing to pay a maximum of $170 per hour for an additional 2,000 hours of temporary staff time. So if we hire temporary staff time, that's an additional labor. Remember, the original labor is $45 per hour from the question. Do you still remember that? So if we add 125, we are going to come to 170. So if we hire temporary staff, we are adding the labor resource. So in total, we should be willing to pay $170 per hour for an additional 2,000 hours of temporary staff time. So this statement again is correct. So both 1 and 2 are correct. Is that clear, madam? Hello? Oh, yeah. Muripo iri.
Iripo se mboparowa futhi chone.
So tiri kuti shadow price zvainoita. Shadow price inongoreva kungoti ka extra premium kamunobhadhara kana ka extra contribution kamunowana, handiti ka kana mukange mawedzera a unit of the scarce resource. A unit of the scarce resource. No shadow price zvairi. Anyway, you read, I'll supply you again the examiner's answer where he explains further. Maybe you might understand one or two, but what I'm trying to say is the wording for you to know, to understand. You just have to know that a shadow price is an extra contribution you are going to earn. All right, if a unit of a scarce resource is added, all right, or the extra payment or premium you are going to pay should you acquire that additional, an additional unit of the scarce resource. All right, number 24. What is the maximum profit which can be earned in month 3? Maximum profit which can be earned in month 3. Now, month 3 information has been given by the linear programming graph there. Maximum profit. You need to understand what is called the feasible region. This is the feasible region. Do you understand? The feasible region. This is the feasible region. All right. Now, the feasible region tells us of the points where we can get the maximum contribution or the maximum profits, especially on these edges. That's when we get the maximum contribution. But now, there is what is called the ISO contribution line. Do you understand? Do you know that line?
I just know it's at the far end between 2000 and 2000 there, somewhere down there.
No, the ISO contribution is this one. This
ISO
line.
contribution saying
ISO.
Between two, and between two and y-x is 2000 and then xs is 2000, between 2000 and 2000. So you can really dotted sometimes. I just observe sometimes it's dotted.
Sometimes it's dotted. Yes, that's fine. So our prayer is that, this ISO contribution, if it is moved this direction, it will be telling us the production combination that is going to give us more contribution. So if we continue to move this line further, it will come to this point. So this particular point. This is where we have got the optimum contribution. All right? That's the point where we have got the highest contribution possible. Now,
what do you say so?
Okay. This is the point where the feasible region is intersected by our constraints, right? Okay, it is actually the farthest in terms of you might argue and say, what about this point? What about that point?
Which point?
This. Are you seeing my pen? There is this point number 1, point number 2. Also, those are also edges. They are also edges of the, of the feasible region, right? But now, at this point, for example, at point number 2 there is 4,000 units of sea batch, but 0 in terms of head off. There is no head off here, right? Which might not be good and optimal. All right. At point one, there is something like 3,000 head-offs, and 0 of C batch, it might not be as optimal as possible again. So if we look at all the points of the feasible region, we can actually see that this point 3, let me just say point 3, is the point where we are likely to have the highest contribution possible. Is that clear, madam?
Yes, sir.
Good. So in the exam, we are like this question is saying, give us the maximum profits which could be earned in month 3. What is the maximum profit which can be earned in month 3? So we first of all have to find the total contribution, and then we deduct our fixed costs. So total contribution, we have been given that the contribution per unit, we know that the contribution per unit information has been given here. The contribution per unit. Are you seeing that?
250 and 315.
Yes, that was the contribution per unit. But now we want the total contribution. So the graph is telling us. So we come here, let us do it step by step. Contribution, country per unit. I need some headings for the products, because if you don't put the products, somebody can be easily thrown overboard. So we have got C batch, we've got the head of. All right. So the contribution for the C batch was 250. For the head of 315. All right. Then the units. The units now are shown in the graph. The graph is saying how many C batches have been produced according to this at this intersection at this point, at point 3. We can see that in terms of C batch, we are having 2,000, isn't it?
Yes, sir.
This is the 2,000 we are talking about for the C batch. Why? Because this line, that's the line that tells us that the C batches, remember the C batches are on the horizontal axis. So in terms of C batches, that we are having 2,000. Hello?
Yes, sir.
All right. And then in terms of the head-offs, this is the line, right? At this point, what do you think is the figure then? That's 3,000, isn't it?
3,000.
Good, 3,000. We are
So
done.
why did you pick these two? 2,000 and 3,000. Hello? Okay.
Hello. The intersection here, this is all right. Let me make it, undo the annotation. All right. What I did, first of all, I identified the feasible region. Okay. I identified the feasible region. The feasible region is the region where we can get the highest possible contribution. That's the feasible region, right? But there is what is called an optimum point, where we get the highest possible contribution. All these in this region, a combination is likely to give us some positive contribution, but there is a point where we can get the most contribution possible. and we can be informed by the ISO contribution line. If we continue to push the ISO contribution line towards upwards, if we continue to push the ISO contribution line, this is the ISO contribution line. If we continue to take it to the furthest in that angle, without tilting the line, but maintaining the angle or the degrees, we are likely to reach this point. This is the point which we are calling the optimum point. So it is in the intersection of this line and this line. Are you seeing that?
I see what you're drawing.
But you're not getting the sense.
And they continue saying, we can continue saying. All right.
Okay. To determine the optimal point from the graph, the ISO contribution line, that is the line 250S plus 315. This is the ISO contribution line. Must be moved at the same gradient or angle, right? Through the feasible region until the last point it leaves the feasible region. So the last point, if we continue to push this line, let me again clear up. If we continue to push the ISO contribution line upwards, if we continue to push it upwards, it will come to this point, right? This is the point, the ISO contribution line. Do you get it?
Yes, sir. Oh.
Do you get it? This is the ISO contribution line number 2, and this one was number 1. If we continue to maintain the angle, I'm sorry, I'm not using a ruler, but you can see why I'm saying that is the point we are saying the optimum point. So we are at this point, we are going to have here, there is 3,000 what? Head-offs. Head-offs, and here, down here, we are going to have the 2,000 head-offs. Okay, so if we are having 3,000 head-offs, these are the head-offs, and the C batches, we are having 2,000 units, and the contribution per unit for head-offs, the contribution per unit was 315, and for C batch, the contribution per unit was 250. So in terms of total contribution, that's 3,000 multiplied by 315. 3,000 multiplied by 315, that's 945,000. So 945,000. And we come to the C batch where we are having how much? 2,000 multiplied by 250. 2,000 multiplied by 250. That's 500,000. So 500,000. So what is the total contribution? This gives us
500.
Plus 945,000. 945,000. That's 1,445,000. 1,445,000 less fixed costs. How many fixed costs? How much were they?
I think how much was the fixed cost?
300,000, right?
300,000.
To get it.
And 300,000.
So That's the profit which we are required to calculate. So that's 1.145. Do we have that answer? 1.145. So the answer is D. And somebody would make a mistake and choose option C. If they do not deduct the fixed costs, they are going to be in trouble. If you don't deduct fixed costs, you are going to be in trouble. Is that clear?
Okay. Yes, sir.
So don't forget those fixed costs in your examination. Do not take them for granted and say, oh, it's just any figure. No, it's not any figure. All right, the last question of that part. Which of the following interpretations of the linear programming graph produced for math 3 is or are correct? So which one? Kana wakatarira iwewe linear programming graph iri zviri correct ndozviri kungotaurwa naexaminer wako, izvozvo ndozvaari kungotaura kana wakangoritarirawo. Pane zvinhu zvaunofanira kungoziva kana wakatarira linear programming kuti izvi zviri kumborevei, chii chiri kumbotaurwa ipapo. Graph iro racho graph iri ndombozviziva sei? Because kana patanga tichiverenga graph iri handiti pane zvimwe zvofanira kutongouya mauri. For example, handiti.
For example, yes.
For example, to have a demand for C batch, demand of C batch, that's S is less than or equal to 4,000, isn't it? S is less than or equal to 4,000. That's this one shows the demand, right? This one is for the demand. And this one again is for the demand yema head offs. What's the cause? The atom bodarikishing 3,000. Okay. Then kana wakatarira a combination yema materials. My materials. Remember in month 3, my materials havangopfuura 35,000. Saka unotocheka unotoona kuti okay fine, materials edu tinoziva kuti isusu from initially takaudzwa kuti materials tine 5 kgs for C batch and 7 kgs for head off. So it should actually be for materials the equation should be 5s plus 7h is less than or equal to 35,000. All right. So we come here, 5s plus 7h is equal to 7,000. Toenda futi pachi this one ukangotarira the last figure rotokuudza kuti apa tiri kutaura nezvechiapo, tiri kutaura nezve labor hours. Alright, to prove kuti labor hours toenda futi uku kuchitebho chatakaudza kuti labor hours tinoda 2 hours s2 or 2s and 3h, 2s and 3h, 2s plus 3h. So we come here 2s plus 3h, that's 24,000. Total day labor. So this one, going to wait labor, right? And this one, not in the materials. Then, saka imwe yacho yasara inofanira kunge iri machine hours. Let us verify kuti ndeye machine hours here. Tiri kuona apa yakanzi 12,000. Ngatione kuti 12,000 ndizvo here. Yes. 12,000 machine hours, no maximum hours available. All right. Kwa hiyo ili kuti chi ava machine hours ari kuti 3s plus 2 hours ndizvo here zvakaita equation yacho 3s plus 2h is equal to 12,000 totoziva kuti tagona anditika linear programming redu taripedza iyi ndechi iyi ndeye yatinoti isusu the objective what function objective function yecontribution yacho tatopedza nazvo anditika right takunzwisisa linear programming yedu graph takurwisa taribata takuchienda manje kuti examiner what do you want examiner ari kuti which of the following interpretation of the linear programming graph produced for mass 3 is or are correct. Number 1, even if demand for either product increases, labor will be a slack variable if no other resources change. And what is the slack variable? What do you understand by a slack variable? N? Hello? Hello?
There.
Are you there? What is a slack variable? Okay, a slack variable arises. A slack variable arises when there are more resources than are required. So if we are having more resources than are required, then there is a slack variable at play. So to kind of a graph paper, shown out my slack variables are so about even if demand for either product increases, labor will be a slack variable. Will be a slack variable if no other resources change. So let us see. Where is the labor graph? You can see that the labor graph here is actually outside, far away from the feasible region. The resources which have been consumed according to the feasible region are the machine hour. You can see that this line is actually bordering the what? The feasible region. All right. So it means that resource has been consumed. All right. The hours for machines are all consumed in month 3. But labor, you can see, is outside, far away from the feasible region. So there is more labor. There is more labor. More labor. More excess labor. So there is, this one is a slack. That's a slack. Very far away from the feasible region. So that's a slack. So for labor, even if demand of either product increases, labor will be a slack variable if no resources change. So 1 is correct. What about number 2? If more machine hours were made available in mass 3, they would be used initially to make head-offs. If we were going to obtain more hours, yes, it's correct, the machine hours have been used up, but we are told if we get more hours. So you can see that in terms of that, some students might be caught unaware, might be caught off guard if they are not alert. So you can see that in terms of machine hours, we have already determined that they've been fully used up. But the examiner is saying, yes, we know that you are understanding that they've been used up. So tell us, if more machine hours are going to be added, are we going to do what? Are we going to initially make head-offs? Are we going to initially make head-offs? Is that possible, given that we add So for head-offs, we can see that the demand, remember I told you that this is the demand for head-offs. And it is on the edge of the feasible region again, just like machine hours. This one is on the edge of the feasible region, which means that the demand has been exhausted. So if we get more machine hours, if we were to get more machine hours, was that going to stimulate demand? Obviously not. Okay? It was not going to increase demand. Why? Because the demand is already exhausted. So the availability of machine hours is not going to force the market to buy our head-offs, because we have already supplied enough. Do you get that, madam? Hello? Eddie. Hello? Please. So that's how we are supposed to, maneuver this. So the solution there should be one only. Two is wrong, because it is saying that we will make head-offs. We will initially make head-offs. Why? Because we can't make head-offs in this situation, because the demand for head-offs has already been met, and we can't increase demand just because we have found extra machine hours. They are not related events. Is that clear? So 2 is wrong. So our answer is A. This is the answer. Okay guys, thank you so much. I hope you have been heard in this video presentation. And I hope you will come back and watch this video and correct your position. Okay, easier to move it up. Hello.